The Big Crunch is a theory that suggests the universe may one day stop expanding and collapse in on itself. Instead of continuing to grow forever, gravity could eventually overpower dark energy, causing galaxies to slow down, reverse direction, and move toward each other. As the collapse accelerates, galaxies would collide, stars would be torn apart, and temperatures would rise to unimaginable levels. Eventually, even black holes would merge, leading to a universe compressed into a singularity, a single point of infinite density, much like the Big Bang in reverse. Some scientists propose that this could trigger a new Big Bang, restarting the universe in an endless cycle of expansion and collapse. Others believe dark energy will remain dominant, preventing a collapse. If the Big Crunch is the true fate of the universe, does that mean time and space are destined to repeat forever? Or will cosmic expansion continue indefinitely, making the Big Crunch impossible? True or false? The Big Crunch suggests that the universe will eventually stop expanding and collapse. True. What condition would be required for the Big Crunch to happen? Dark energy weakening over time. Fill in the blank. The Big Crunch describes a scenario in which the universe's expansion blank. Slows down and reverses. Fill in the blank. As galaxies merge and collapse during the Big Crunch, the universe's density would blank. Increase. During the Big Crunch, galaxies would move in which direction? Toward each other. Fill in the blank. If the Big Crunch happens, black holes would eventually blank. Merge into a final singularity. True or false? If the Big Crunch happens, the universe will collapse into a single black hole. False. Instead of forming a black hole, the universe would compress into a singularity, possibly triggering a new Big Bang. Fill in the blank. The theory that suggests the universe cycles through repeated Big Bangs and Big Crunches is called the blank model. Cyclic universe. What would happen to temperature as the universe collapses? It would heat up due to increasing density. Fill in the blank. The force responsible for pulling galaxies back together in a big crunch is blank. Gravity. True or false? Dark energy would need to weaken or disappear for the big crunch to occur. True, dark energy currently drives expansion, so if it weakens, gravity could take over. Fill in the blank. If the universe collapses, the cosmic microwave background radiation would blank. Disappear as temperatures rise. If the universe collapses completely, what could happen next? It could explode in another Big Bang. Fill in the blank. In a big crunch scenario, the universe would eventually shrink to the size of a blank. Single atom. Fill in the blank. If the big crunch occurs, time would eventually blank. Slow down and stop. If the universe went through cycles of big bangs and big crunches, what evidence would scientists need to prove it? If the universe undergoes repeated expansion and collapse cycles, scientists would look for signs in the cosmic microwave background, like patterns suggesting past universes. They might also study gravitational waves or dark energy's long-term behavior to see if expansion has slowed in the past. Another key piece of evidence could be leftover radiation or matter from a previous universe. If these signs exist, they could confirm that the universe is part of an infinite cycle of birth and collapse. True or false? The Big Crunch theory was considered more likely before the discovery of dark energy. True. which factor would most likely prevent the Big Crunch from occurring. The continued acceleration of the universe due to dark energy. Fill in the blank. If the Big Crunch occurs, the universe's expansion would first blank, then reverse. Slow down, then reverse. If the universe were to begin collapsing at a rate of 1% per billion years, how long would it take for the universe to shrink by 50%? To calculate how long it would take for the universe to shrink by 50%, we use the given collapse rate of 1% per billion years. Since we need a total reduction of 50%, we divide 50% by 1% per billion years, giving us a final answer of 50 billion years before the universe is half its current size. What would happen to black holes as the universe collapses in the Big Crunch? They would merge into a single massive black hole. If a galaxy moves toward the center of the universe at 2,000 km/s during the Big Crunch, how far will it travel in 10 billion years? To calculate how far a galaxy would travel during the Big Crunch, we use the formula distance equals speed multiplied by time. The galaxy moves at 2,000 kilometers per second toward the center of the universe. First, we convert 10 billion years into seconds, which gives us 3.15 times 10 to the 17 seconds. Multiplying this by 2,000 kilometers per second, we get a final distance of 630 quintillion kilometers before the universe collapses completely. True or false? During the Big Crunch, the temperature of the universe would increase dramatically. True. Fill in the blank. As the universe collapses, galaxies will move blank each other. Toward each other. As the universe contracts, cosmic background radiation would eventually become more energetic and hotter. Fill in the blank. The final stage of the Big Crunch would result in an extremely blank universe. Dense and hot. or false? If the Big Crunch occurs, galaxies will continue expanding outward forever. False. The Big Crunch suggests that expansion will reverse, causing galaxies to move inward instead of outward. Fill in the blank. A universe that repeatedly expands and collapses in cycles is called the blank model. Cyclic model. What is one possible outcome after a big crunch? A new Big Bang, restarting the universe. If the universe collapses from 100 billion light years across to a singularity in 20 billion years, what is the average collapse speed in kilometers per second? To calculate the speed of the universe's collapse, we divide the total contraction distance by the time. The universe shrinks from 100 billion light years across to a singularity in 20 billion years, which equals 9.46 times 10 to the 23 kilometers. Converting years into seconds, we get 6.3 times 10 to the 17 seconds. Dividing these values, we find that the collapse speed would reach an astonishing 1.5 million kilometers per second, making it one of the fastest events in cosmic history. How did you do? Tell us in the comments below. And thanks for watching BrainyKidz. We hope you had fun learning today. Don't forget to like, subscribe, and hit the bell so you never miss a new quiz. See you next time, Brainy friends.